along the edge of the circle. Okay, so how do I figure out how long that one little piece of an arc is?
Is it because of the angle, since you drew the angle from the
Yeah.
the
Well,
It's not pi, it's gotta be pi.
won't the size of the angle affect?
Pi over 360 or something like that.
Okay, well, we know that we can measure. That's what radians do for us. Radians give us a measurement based on the side of the angle. So they said, okay, we know. They actually defined, when they defined radians, I'm going to back that out of there. They defined a 1 radian angle. If you have a 1 radian angle, it's the angle in which the arc is the same length as the radius. If you have a 1 radian angle, the arc and the radius will be the same amount. That's how they define it. So consequently, if I want to do any other sized arc, say I just come over here and throw another arc out there. And by the way, we call arc length the letter F. I don't know why. It's F. So if I want to know that, and I know it marks off a certain angle, would these not be proportional? So yeah, you can say the arc length F is to the arc over here, which is whatever the radius is, and then my angle would be proportional to the angle of 1 radian. Okay, how do I solve for F?
F is radius or is radius?
Radius. R is radius, yeah. So to get S by itself, don't I just need to move R?
Yep, that's right.
So I multiply R over, so that will write it as R times theta. Since I'm dividing by 1, that doesn't change anything. So I actually end up with R times theta. And folks, that's the formula for finding arc length. Okay, you will not have to memorize these formulas. I will give you these formulas. Okay, so, yeah, it's very easy. Now, the key thing is, though, this was defined in radians. Whenever you use this formula, your angle must be in radians. So if they give you degrees, you have to convert it to radians before you can work the problem.
What the score is?
We have to know the
We have
radius
to do
and the
O in radian and after divide by radian.
Radians is the measure of the angle.
Yes.
R is the measure of the...
Radian and if it O is radian.
Oh, yes, that's radians too. Yeah, yes, that's radians too, so those would have canceled, if that's what's bugging you.
So it's divided by 1.
Yeah. So yes, it's divisible. So it's just dividing by 1, which is, so when I multiply it, it's just R times theta.
So if we find the angle in degrees, we have to switch it.
You'll have to convert it, you'll convert it to radians immediately as soon as you will go to fill it in the formula. So we're going to convert a whole bunch of these real soon. All right, so let me draw you a circle here, and I'm going to tell you that you just cut off here. We have chopped off an angle of 120 degrees? No, 144 degrees. Okay, so say that's 144 degree angle. Notice, degree. 144 degrees. The radius of this thing is 120 millimeters. Find the arc length. Okay, so arc length is the radius times the angle. What's the radius? 120. And the angle has to be in radians. So if I have 144 degrees, how did you convert to radians?
Pi over 180.
Yes. And so you'll just write it as 144 times pi over 180. Just slap that in there. You just will put a pi over 180 on it every time it's in degrees. And then you will throw that in a calculator. We are going to leave pi in the answer. You're going to evaluate it out. So if you actually throw that in a calculator, and we're going to go ahead and go 3 significant digits, even though we're going to say that 0 was significant there. And it rounds off to 302. 302 what? What kind of unit was I using?
It'd be milliliters. You said the radius was
It would be millimeters. Now this is the part that's weird for people. This was 120 millimeters, and I multiplied it by radians. I took millimeters times radians, and I get millimeters.
You gotta use what the first measure the radius.
No.
Because you remember, yes, the other day when I defined what a radian was, we defined it in terms of a unit circle. Radians, it's like they absorb whatever unit you're working with. It was done on a circle of any, they expand to any size, so radians become whatever unit of measure. That's the beauty of radians. That's why we can combine angles with lengths on here, because radians just take on whatever unit of measure you're using. It's weird, it's strange, but it works. It's cool. That's why NASA couldn't do what they do without this. Okay, so that's one example of how you're going to do this. If you let me give you another one. Oops. Okay, this is Earth this time. Okay, here I'm telling you, you have, this is New Orleans, Louisiana. It's at a latitude of 30 degrees. And then up here farther north, directly north there, exactly north of each other, this is a place called Grand Portage, Minnesota. And it's at a latitude of 44 degrees north. Okay, I want to know what's the distance between the two cities. So what do you do?
Well,
Wouldn't it be just the length of the arc of the Earth here? So I need to find the arc length. To find out what's the distance, they're right above each other on, yeah, they're directly north of each other on, they're on the same line of longitude. That helps? So north and south there are the same. So therefore, what's the angle between them? 14, yeah, 30 to 44. That's 14-degree angle. I need to know what the distance is between the two cities. So I just need to know arc length. So, oh, sorry, got to tell you the radius. The radius of Earth, they tell you this in the book. And they do it in kilometers, don't know why, but yeah, sorry. Radius of Earth is 6,400 kilometers. It's a significant digit. So, okay, we got a radius of 6,400 kilometers times an angle of what?
14 pi over 180.
Because I'm doing this formula. Why did she say 14 pi over 180? It's in degrees. We need to be in radians. So 14 pi over 180. You throw it in a calculator. Now, the calculator is going to produce an answer of 1,564. But they're going to round to significant digits. So where are they going to round to?
Well, since using 14 when it was 6.
That's 2. 6,400 was 2. So you'd have, they'll round that off to 1,600. What units? Kilometers. Yeah. So they like their significant digits.
Grand Portage, Minnesota.
So that those.
Are miles longer than kilometers, or
Yes.
kilometers longer than miles?
Yeah, miles are longer.
It's like imagine that up in the center of the earth.
I don't remember the whole conversion.
Like 1 point.
1 point something, but
No, 7 is the degrees Celsius. So 1.2, 1.3.
yeah. We don't convert between the two of them. You work in one or the other.
We should all work in kilometers.
Yeah, we should. We should be metric totally. Oops, I shouldn't do that yet.
We should be on the metric
We should be metric totally completely. Life would be so much simpler.
I prefer Fahrenheit.
Okay. That's a tree.
Looks like a volcano.
Okay. Sometimes we use arc lengths to find distances that are truly actually straight lines, but because they're so far away, the arc would be so, because it's a tiny piece of the arc, it's virtually like a straight line. For example, if you have a problem on your assignment where you're going to find the diameter of the moon using arc length, because the distance so far out, that angle is so small, that it's virtually a straight line. when you get out to the arc. So this is a sort of earthly example. I don't know that it's perfect. I'm telling you that this is a 50-foot tree. Okay? You're standing back here an unknown distance away, and the angle is 1.2 degrees. How far are you back?
You're pretty far back.
You're pretty far back. So that's the point. My arc of my curve would be so very slightly curved that it's almost a straight line. So if it's a long distance thing, we can use arc length to actually find distances that are straight. So I'm going to still use arc length to do this. What's x in this case? What don't
X is the radius.
x is the radius. So that's what I'm trying to find is the radius in this case. So what's the arc length?
50.
The 50. And then I need the angle.
1.2 pi over 180.
1.2 pi over 180, yes. So how do you get solve for r?
Divide by that stuff over.
Get the pi there.
So if I divide that over, won't I just be multiplying by the reciprocal? So I would just do it as 180 over 1.2 pi. Make sure you get that pi on the bottom of the fraction when you punch it in your calculator. Times 50. You're going to throw that in a calculator, and once again, your calculator is going to tell you something like 2,387, but you're going to have to get that down.
Would you have to get it down over?
Well, you have to look at the numbers in your problem. Assume the 50, assume that was significant. It was exactly 50 feet.
So it's 2.
That's 2, this is 2.
2,000.
So if I round that to 2, 2,400 what?
Feet.
Because we were doing it in feet this time, yes. All right. Woo! That was exciting. That's arc length. Well, if you can do length, you can do area too.
We're not always trees, aren't we?
No, we're doing 4 things today. This is one.
Well, you better speed it up.
Area is really short. Okay, if I say I want to do area of a sector, what's a sector?
Like a little piece of pie.
Yes, exactly, a piece of a pie. I always put that in the wrong spot. I got to remember this thing draws from the center. There we go. Okay. So, yeah, if I want to do area of a sector, I want to take a pie-shaped sector of my circle, and I want to find that area. Okay. So wouldn't that just be a fraction of the whole circle?
Yeah.
Yep. Okay. So what's the area of a circle?
Pi times diameter or 2 pi r.
That's circumference.
What are you asking for?
Area of a circle.
Pi radius squared, pi radius squared.
Pi radius squared.
Yeah, pi radius squared.
Too many formulas for circles.
Okay. So if a circle has an area of pi r squared, this would be a fraction of it. So if the fraction of a circle, if I tell you, you know how big the angle, I'm going to tell you how big that angle is in there.
Like feet now.
If that angle is 30 degrees, how do I figure out what fraction of the circle it is?
Will be 30 over 360.
Wouldn't it be 30 out of 360?
Yeah.
Okay. But we actually need to do this in radians. So instead of my saying this angle is 30 out of 60, in radians, what's a full circle? 2 pi, thank you. So if I want to say do a fraction of it, then my fraction would be whatever this angle is out of 2 pi. Yeah, amen. And then, so I would have that fraction of a circle times pi r squared would give me the area of my sector. Because going around the circle is 2 pi. If you go completely around the clock, it's 2 pi. Okay. So now, reduce it. Simplify it. What do you have here?
Circle.
Your pi's cancel. I'm going to make that just a 1/2 out front, that 2 on the bottom. So it's 1/2, you got the angle, and you got the radius squared. And that's the formula for area of a sector of a triangle.
So now we're going on the circle. So now we're going on the triangle.
We're going area, right here.
Great.
The angle, they have to tell you how big the angle is in the problem.
So now we're going.
we don't know the angle?
There, yeah, so I'm going to tell you here, this is my classic example. We have a cattle lot on a hillside.
Is it yours or is it you just making this up?
No, yeah, for real. I mean, I asked my husband to roughly estimate distances for me.
Why do you have a cow on the side of a hill?
So the manure runs down.
What if the cow decides, you know what, heck with it, they go to the top of the hill and they charge the gate and
There's 4 silos up here. There's a silo and loader. The feed runs down the bunks on each of these fences.
Oh, it's 4 different lots.
Yeah, this is different lots.
Hey, how's the cow? What's on the bottom?
A fence.
I'd charge that fence so hard.
So, okay. If this is 45 feet, and I'm telling you the whole thing across there is 120 degrees, assume those are divided in 3 equal slots. I didn't get it drawn real equal, but assume they're equal. So I want to know how much area in one lot. Very good. It would be 40 degrees each. So therefore, if you're going to take your area formula, you're going to go half. What are you going to put for theta?
45. It's 40 degrees.
Be 40. It's still in radians, yes. Everything you do today is in radians.
Are we gonna be doing radians for the rest of the year, basically?
On and off. This is,
The radius
and then I need the radius,
would be 45.
which would be 45. Squared, because the formula says squared. Once again, you jam it all in a calculator, and calculator will produce 707. What would we round it to?
700.
How many significant digits do we have? 2. 120 was 2.
So 710.
So they would round it to 710. What? It's area. So it'd be square feet. So areas all have to be in square feet. Square what, meters, square miles, whatever you're doing. So area will be squared. That's area. If you have a problem on your assignment, you get to figure out how much area the windshield wipers are doing. If they're windshield wipers that work from the top. Go this way.
And then we use statistics to calculate what percentage that is.
So there's all kinds of things you can do.
No, no.
Oh, thank you, Jess.